sixth graders, in lesson 5.2, we're going to talk about adding and subtracting fractions. Now, let's go back to first and talk about what a fraction tells us. Who can tell me what a fraction tells us? If we have a fraction like 3/4, what does that fraction tell us? Olivia?
That there's like four, there's like a whole pizza and there's 4 pizza slices and then 3 got eaten.
Okay, so it might mean 3 are eaten, 3 have been taken away, or maybe there's 3 left. The 3 tells us how many pieces, and the 4 is what we're going to talk about right now. The 4 tells us the what?
The whole amount.
Okay, the whole amount that you can make out of the total, or it tells us the size of the pieces. Okay? It tells us the size of the pieces we're working with, and that's really important. I think this is mine. So please don't waste. Pay attention. The size of the pieces. So, look up here. Put your pencil down. Unless you're taking notes. Look at this example. Let's say that we have 3/4. Okay? And we need to know if we can give away 5/8, or how much would be left after we take away 5/8. Well, if we just have this piece here, how would we take away 5/8? This pizza is not cut up into 8 pieces, so we can't take away 5, we only have 3. So what do we have to do to take away 5/8? Peter?
You would, since 4 is a multiple of 8, you times it by 2, so it's 8, and you also times 3 by 2, so it would be 6/8 minus 5/8.
Okay, we could change this to 6/8. That's exactly what Peter described, is to change this to 6/8. Okay? Now, what are we literally doing to the pizza? How are we changing it to 8s? How are you changing it to 8s if you have 4ths? Allison?
You're just cutting the 4 pieces in half of them.
Yeah, we're cutting them in half. We're taking these, and we're actually going to take all of these, but cutting it up into 8s. We're making 8 pieces out of 4, cutting it into 8s. Or, to do the math, we are multiplying the numerator and denominator by 2. Now, why did we choose to multiply it by 2? Peter also said that. Why did we choose to multiply it by 2 to get 8? Why didn't we just cut them up this way and make 20 pieces? Why not just cut it up into a whole bunch of pieces and then take away 5? Nate?
Because it won't be the exact answer.
It won't be the right amount. We have to take away 5/8. Okay, not 5/20ths or 5/3 or 5 of anything else. We have to take away this amount, 5/8, or in other words, 5 pieces that are cut up into 8s, that are the right size. And so we choose the right size by making both of the denominators the same. It's called a common denominator. It's actually a common multiple of the denominators. We learned about common multiples. So, we have to use multiplication or division to make the pieces the right size. And then, whatever you multiply the bottom number by, whatever you multiply the denominator by, you have to multiply the numerator by. You gotta look up here. So if we multiply 4 to get 8s, or sorry, multiply 4 times 2 to get 8s, Then you have to multiply 3 times 2 to get the number of pieces that you have. Okay? Now, if we have 6/8, can we take away 5? But you have 6, can you take away 5?
Yes.
Yeah, you can take away 5/8 because you have 6/8 equals 1/8 left. Oops. We have 1/8 left. One of these small pieces left. Okay? Or if I were just to erase these, we'd have 1/8 left. Okay? Does that make sense? Take away 5, 1, 2, 3, 4, 5, we'd have 1 piece left. Let's go to our assignment in the book. Page 142. What if we have one whole, and we need to take away 3/8? How would we draw this out? Let's say that we have a pan of bars. We have a whole pan of bars, and we're gonna serve 3 pieces, 3/8. What do you have to do? Bennett?
Isn't it the 1 into 8 base?
Yeah. So we'd cut up the pan of bars into 8s. Now we have 8s, okay? And so we change the 1 to 8/8. Does everybody see that?
Mm-hmm.
You write 1 instead of 1 whole, we make 8 pieces. Cut it up into 8s. We write the number 1 as 8/8. We have 8/8. Does everybody see that? Nod your head if you see that. We have 8/8. Okay? Now, we can take away 3 of them. Let's say that we get rid of these. How many are left? 5. 5/8 left. Okay? We have to have the same size pieces. We have to have the same denominators whenever you're adding or subtracting. Alright? Let's do an addition one. Let's say that we are on example number 1, 5/6 plus 4/9. Okay, now we have 5 pieces that are in 6ths, and we have 4 pieces that are in 9ths. Yeah, we do need the denominator. Yes, we have to know, to get the exact amount, we have to have the same size pieces. So we're going to have to cut the 6ths up and the 9ths up so that they are the same size. What's the common multiple that we could use? I'm going to write it down here, and this is how I want you to show yours. This is how I want you to show your work. Abby? 18ths, yep. 18ths is the common multiple we could use. Now, we could use 54ths even. We could use other numbers. We could use 36ths, right? But 18 is the lowest common multiple. Now, how do you get from 6 to 18? What do you have to do to 6 to get 18? Using multiplication.
Times 6 by 3.
Yep, times it by 3. Now, do you know this dot means times?
Yes.
Okay, good. It does, yep. The dot in the middle is the times sign. So, 6 times 3 is 18. That means we have to do 5 times 3, and that's 15. So these two are equivalent fractions. What do we have to do to 9? Matt? get 18.
So, divided by, times it by 2.
Yep, and so what do we have to do to the top number?
Times it by 2.
Yep, and so that equals
8.
8. 18. So we're going to add these.
I tried to say.
Okay? So, do we add the bottom numbers? No, the bottom numbers are just telling us what? What does the bottom numbers mean? What do they mean? What are they just telling us?
The size of the slices.
Yeah, it's the size of the slices that we're using, or the size of the pieces that we're adding. We have to add the total number of pieces. These are the pieces. How many pieces do we have? Come on, people. One person knows. Olivia? 23. How big are they?
18.
How big are they? 18ths. They're in 18ths. Now we can change this to a mixed number. 1 and 5 18ths. Right? What we would do is think, how many times is 18 going to 23? Once. Now, what would the remainder be? We could make one whole then. What would the remainder be? 5. 5 left over. So we put the leftovers, these are the leftover pieces, and they're 18ths. So put the leftovers over the denominator. Okay? Any questions on that? Olivia?
Wouldn't you have to use 3 for the 4 9?
3 for the 4 9.
Like how you do 6 times 3?
No, we have to use whatever number we multiply by the denominator.
So you have to get the same answer as, so like,
So to change 9 into 18, we have to multiply it by 2, right? That means we have to multiply the numerator by 2 as well, by the same number.
yeah.
And 4 times 2 is 8. Does
So
that make sense?
yeah, but so anything that has like anything, the number.
Alright, just think about it a little bit, see if you can formulate your question. Okay? And if it comes to you, then you can ask it. Alright, I want you to practice on page 144. And I want you to do 2 through 6 and 13 to 22. Okay, 2 through 6 and 13 to 22. Okay? And 13 through 22.